Welcome to Study Loop.
Our question says, a ball is thrown horizontally from the roof of a building that is 9.0 meters tall and lands 9.5 meters from the base. What was the ball's initial speed? Okay, so I wrote down here what we were initially given in the problem, and that is that the ball is thrown from a height of 9.0 meters. Okay, but I'm going to choose downward to be the positive y direction. And I'm going to say that the origin will be at the point where the ball is thrown from the roof of the building. On that way, the distance the ball travels, y, is going to be 9 meters, right? And then the distance the ball, it also tells us the distance the ball travels in the x direction is 9.5 meters. And since the ball is thrown horizontally, the initial velocity in the y direction, vy of 0, is going to be 0. And the velocity in the x direction is what we're going to try to be finding. And we know, since we're on Earth, that the acceleration in the y direction is 9.8 meters per second squared, and there's no acceleration in the x direction. Gravity only acts in the vertical direction. So the time of flight first needs to be found. And once we know the time of flight, since we know the time of flight and we know how far it flies, we'll know the velocity in the x direction. So to find the time of flight, we can use equation 2-12b for the vertical motion, okay? Because the time it takes for it to fall vertically is the same time it's going to be in the air horizontally. Now, that equation is y, the distance it travels vertically, is equal to the initial velocity in the y direction, or I'm sorry, the initial y point plus the initial velocity in the y direction. And that's in meters per second, but we need this in meters to add it to y naught, which is in meters. So we multiply it by seconds, or the time it travels. Then you have 1/2 integration constant times the acceleration of gravity, right, in the y direction. And then that's meters per second squared. Ooh, forgot my second squared over here. Meters per second squared. So we need to multiply this by the time squared to get rid of the second squared. Okay. Well, our initial point is the origin I called 0. So y naught is equal to 0. So we don't have to worry about that, right? This goes to 0. And vy of 0 is 0, right? So this multiplication here goes to 0, so we don't have to worry about that. So now we are left with y is equal to 1/2 a of y t squared, right? But we want to solve for t squared. So t squared is equal to 2y divided by acceleration in the y direction, okay? Which means that t is equal to the square root of 2y divided by acceleration in the y direction. Okay, so now we just need to plug in those values. So if you plug in those values, you find that t is equal to square root. 2 remains 2, of course. Y is 9 meters, right? Divided by 9.8 meters per second squared. Okay, and if you plug all that into a calculator, you find that this equals to 1.36 seconds. All right, now that we know how long it's going to travel, we can use the fact that it traveled a distance of x, which x is equal to the distance traveled is equal to v of x times the time. So v of x0 is equal to the distance traveled divided by the time, which is 9.5 meters, right? Divided by the time, which is 1.36 seconds. If you carry out this calculation, you'll find that this equals 7.0, and meters per second are the units. Box that in, that's our solution.